The phospholipid bilayer consists of two layers of phospholipids. They have a hydrophobic, also known as water-hating, interior, and a hydrophilic, or water-loving, exterior. The hydrophilic head, or polar head, and the hydrophilic tails are the fatty acid chains, and are illustrated as a single
Keep going.
phospholipid molecule. The polar heads and fatty acid chains are attached by a 3-carbon glycerol unit.
Receptor proteins are proteins used in intercellular communication. Receptor proteins play a major role in responding to important information and filtering out unimportant information. There are specialized proteins that are able to bind to signal molecules that receptor proteins recognize. Once they have received the signal molecule, it then enables the cell to respond. These responses can occur to the following ways: by causing changes in the permeability of the membrane, by triggering the formation of the second messenger inside the cell, and by activating enzymes inside the cell, like when a signal protein tells a muscle cell to expand or contract. The molecule that moves diffuses passively through the phospholipid bilayer requires no energy. The molecules move from high gradient to low gradient. They continue to bounce around until they are doing it at the same rate. When this occurs, we see an equilibrium. The ion channel protein is a single protein that traverses the lipid bilayer of a cell membrane and form a channel to aid the movement of ions through the membrane. Ion channels may be open or gated. Molecules cannot diffuse to the lipid bilayer. They use the ion channel protein with a polar core, which allows them to cross.
The signal molecule binds to the receptor protein. This can cause changes in the permeability of the receiving cell by causing the formation of the second messenger, which acts as a signal molecule in the cytoplasm. The second messenger is the molecule that passes the message from the first messenger to the cell. It can also change the functioning of the cell.
Go.
The carrier proteins bond and drag molecules, mostly amino acids and sugars, across the lipid bilayer. They then release them on the other side. They do this through active transport and felicitated diffusion, or passive. Marker proteins are attached to a carbohydrate on the cell's surface and help other cells recognize their type.
Cell surface markers are proteins expressed on the surface of cells that often conveniently serve as markers of specific cell types. Why would you say things are not so good?
Still recording.
Glycoproteins are proteins with carbohydrates attached. Identify the cell type and allow cells of the same type to attach to each other. Cholesterol are embedded in the cell membrane. Cholesterol adds to the firmness of the cell membrane, but also helps maintain the fluidity of the membrane. Without it, the membrane would be too fluid, too firm, or fall apart. Three positive Na molecules and one ATP bind to the protein pump. Hydrolysis of ATP phosphorylates the pump protein and changes its shape. The shape change releases Na outside the cell and enables K plus to bind the pump.
Positive. Yeah, K positive.
Release of potassium returns the pump to its original shape, releasing potassium positive to the cell's interior and once again exposing the sodium positive binding sites. The cycle repeats. Endocytosis pinches the membrane and molecules fills vesicle with material from outside the cell.
Okay.
Exocytosis is where vesicles filled with molecules go through the plasma membrane and exit, or the opposite of endopsychosis.
Psychosis.
Thanks
for watching.